Hello, this is Dr. Strickland. In this video, we will begin our introduction to forensic chemistry. Now, forensic science deals with the application of science to crime solving, and a major focus of forensic science crime labs is the chemistry of evidence. Understanding how this works is like building a structure out of Legos. We start with the foundation and then add more bricks one at a time. And our foundation is matter, because we need to know a fair amount about the states of matter and the classification matter in order to have a solid foundation to begin. So there are three states of matter that you see right here: the solid, the liquid, and the gas. And you know that. Solid, liquid, gas, and sometimes people call the gaseous state a vapor. Okay, so these different states have different properties that are based on the distance between molecules and the attractive forces that can operate at those distances. But the things that we see, the things that we observe, are the different properties, right? Like with a solid, it's all in one chunk, right? Because it's got a definite volume and a definite shape. A liquid can flow. And so because of that, it takes the shape of its container, but not the volume of its container. And with a gas, gases can flow, although sometimes that's harder to observe. But a gas will take not only the shape of its container, but also the volume. And so we know those things, we can observe them and measure them. But the why, the how, is the distance between the molecules and the attractive forces that can operate at those distances. So these different properties that we see are the evidence. This is just like being in a forensic lab or at a crime scene and going, what do I see? What do I hear? What do I smell? The physical properties that we observe give us clues or evidence about the forces that hold these atoms and molecules together. Because with some substances, the smallest piece, say represented by that sphere there, sometimes they're individual atoms, sometimes they're molecules, sometimes they're ions, and we'll talk about all those. But what we do know, and what we think is the basis for producing these properties that we were talking about, is that the very smallest pieces are very close together in a solid. And we think they're very close together because there are attractive forces that are strong and hold them together tightly. When you add some heat, it loosens up some of those attractive forces, and the individual pieces can move a little farther apart. Not all the way apart, but a little bit, enough to flow. If you add a little more heat, those attractive forces can be broken all together, and the individual pieces can separate and go wherever they like. Okay, so let's talk about not just state of matter, but classification of matter. Now, matter is defined as anything that has mass and takes up space. Now, it could be invisible to just our eyes. You might need a microscope. So it takes up space, so it can be like air, has mass, can be like kangaroos, and lots of things in between. Two big groups of matter are pure substances and mixtures. And in pure substances, we're dealing with elements and compounds, and we'll spend most of our time here. Elements each have a box on the periodic table. And we'll talk more about that. Every compound has its own molecular formula. But the thing about all pure substances is that they can't be separated into simpler substances by physical processes. Things like filtration or dissolving or distillation or magnetic force. The kind of processes that you would use to separate, say, the components of a mixture. All right, so, but one thing that's handy, I think, is to use circles to represent atoms, and then we can do a little bit of drawing with some elements and compounds. So let's do a key. And we'll use a completely filled up circle to be carbon, and a completely open circle to be oxygen, and a circle with stripes to be hydrogen. Now, a lot of elements exist as individual atoms. And so carbon is one of those. So I'm going to draw 3 carbon atoms, just 3 colored in circles. And think about soot, which is all carbon, or graphite, or even diamond. And all of those carbon atoms are individual. The smallest piece of carbon is just individual carbon atoms. But there are 7 elements, oxygen is one of them, where the smallest piece is a diatomic molecule. 2 atoms of the element that are just hooked together. So I'm just going to draw a couple of oxygen molecules. This is what's dissolved in, say, in lake water. This is what fish breathe, as well as what's in the air that we breathe. Now, a compound is pure substance made up of the atoms of 2 or more elements that are chemically bonded. So you can have something that only has 2 atoms, but they're different. You have 2 atoms over here, but they're the same. So for water, we need 1 oxygen and 2 hydrogens. All right, so let's get another one drawn here. I want you to pause the video and draw me a couple of carbon monoxide molecules, and then come on back. All right, welcome back. So carbon monoxide is a carbon bonded to an oxygen for right now. When 2 atoms are bonded, we're going to draw them just right up next to each other like that. Very good. Okay, so I want you to see before we stop that we have, not only are we talking about elements and compounds, but molecule is a different word. And a molecule is just a group of 2 or more atoms that are chemically bonded. If they're the same, it's the molecule of an element. If they're different, it's the molecule of a compound. So we have a molecule of an element, such as oxygen, and we have molecules of compounds up here. We've got water, and we've got carbon monoxide, and we'll talk more about that later. Okay, so please answer the question at the end of this video, and then come on back.